In this video, we're going to look at a few problems where we're going to actually calculate some probabilities. So first, we're going to check out some problems dealing with a standard deck of cards. And I've gone ahead and I've brought that sample space over here from the PowerPoint so that we can check that out as we do these problems. So remember, we want to find the probability of drawing the card they're telling us, which means we are always thinking of that one equation. The probability of a certain event happening is the number of ways that E can happen divided by the total number. So for a deck of cards, it's kind of convenient because there are 52 cards in the deck, so the bottom of that fraction is usually just going to be 52. So let's think about this. The probability of drawing a jack. If I look at the sample space for a deck of cards, I notice that there are here 4 jacks. So when I go to do this problem, there are 4 cards that I can draw that are part of my event out of the 52 in the deck. So the probability of getting a jack is 4 out of 52. And sometimes it's easier to compare these numbers if you turn them into decimals. So I can turn this into a decimal, which is about 0.0769. Or you can leave it as a fraction. That's fine. And you don't have to necessarily simplify fractions, because sometimes it's easier to leave it unsimplified so you can see where the numbers came from. Next one up is probability of drawing the 8 of clubs. Well, if I look at the sample space, for this one, there's actually only, not that, 1 8 of clubs right there. So, still 52 cards in the deck, the probability of drawing the 8 of clubs specifically is 1 out of 52, which again, if you want to throw that in your calculator to find a decimal, is 0.0192. So not very likely. That's a less than a 2% chance of drawing that card. A 3 or a diamond. This one we have to be careful with. Let's come over here. So here are all of my diamonds. And here are all of my 3s. I want to count how many cards that is. But I have to be careful. I don't want to count this one twice, because I don't have 2 chances to draw it. It's still only 1 physical card. So if I count this up, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cards that are either a 3 or a diamond, or both. So my probability here, the probability of 3 or diamond, is 16 out of 52. And again, if I want to turn that to a decimal, we're going to get 0.3077. And then for the last one, probably drawing a 3 or a 6. Well, I've already got my 3s highlighted. They're right there. And my 6s are right here. There's no overlap in this one, so nothing to be careful about. That's 8 possible cards. So the probability of drawing a 3 or a 6 is 8 out of 52. And again, turn that into a decimal, 0.1538. Number 2, moving away from cards. A family has 3 children. What is the probability that they have exactly 2 girls? Well, we did this sample space in the last video, and I moved it over here. Right, we made our tree diagram, and we listed out all the possibilities. We now want to know what is the probability that they have exactly 2 girls. So we have our sample space. It's right here. That's our sample space, with 8 possible outcomes. So how many of these have 2 girls in them? This one does, boy, girl, girl. This one does, girl, boy, girl. And this one does, girl, girl, boy. So there are 3 of them out of 8 that have exactly 2 girls. So the probability of 2 girls out of 3 kids is 3 out of 8, or again, if you want to get a decimal, 0.375. So a 37% chance of having exactly 2 girls out of 3 children. Third problem up in the last one, we're going to look at the dice now. So we want to roll 2 dice and find the sum, add them up, like you often do if you're playing a game like Monopoly, right, to see how many spaces you move. What is the probability of rolling a 7? So let's look at our dice. I told you in the last video that if we're looking for sums, we can look for them along diagonals. So specifically, 6 plus 1 is 7, 5 plus 2 is 7, so this is my diagonal right here. All of these add up to 7. And there are 1, 2, 3, 4, 5, 6 possibilities for getting a 7. Out of, we said earlier, there are 36 total possibilities on that diagram. So 6 out of 36. Again, if you want to turn to a decimal, this comes out to 0.1667. A sum less than 5. So let's check that one out. Less than 5. Well, if we are just talking specifically less than 5, that means I'm getting a 2, a 3, or a 4. Remember, it's impossible to get a 1. So this works, these work, and these work. 5 itself does not work, so I can't count these. So 1, 2, 3, 4, 5, 6 again. That's a coincidence, not something special. So in this case, the probability of getting less than 5 is 6 out of 36 again. And the last one, a 2, 11, or 12. So let's go ahead and highlight all of those. Let's erase this first. And we'll keep using green. So a 2 is right here. An 11 is either of these, and a 12 is right there. So a 2, 11, or 12 is 1, 2, 3, 4 possibilities. So the probability of 2, 11, or 12 is 4 out of 36, or if they're in the calculator, it's 0.1111. So now you can kind of get the idea of how you can find probabilities when you are going through and doing problems with sample spaces. For your homework, I have some more problems here that you'll be checking out where these sample spaces will still be useful, right? You're rolling dice or rolling 1 die, and we will be checking those out for your homework assignment.